Question number 1. Will the equation make a parabola or a circle? Now, if you just watched the video on vocabulary, I just covered with you how easy it is to tell whether an equation in this unit is going to make a parabola or a circle. And the way you figure it out is this. A parabola is going to have a y variable that's just by itself. It only has an exponent of 1, and we don't have to write that down. A circle is going to have a variable y squared. Both of these are going to have a squared x variable, but only a circle is going to have a squared y variable. So if you take a look at letter A, our y variable does not have a square on it. And that means this must be a parabola. Just like we learned last unit, all of our equations last unit in quadratics had a y variable that was not squared. Now take a look at this one. This one has a y squared. If you multiplied y plus 2 times y plus 2 and you converted that to standard form, you'd have a y squared. That is going to be a circle. This next one, easy enough. We've got a y variable that is not squared. That is a parabola. This next one, well, our y variable is squared. That means it must be a circle. And then our last one, if you look at this, the y variable here is not squared, and that means it must be a parabola. So really, to tell the difference between a parabola and a circle, look at the y variable. It's going to tip you off. If y is squared, then the curve is going to curve around. Instead of just making a parabola, it's going to keep on going around until it meets itself again and make a circle. If the y variable has no exponent or is just raised to the exponent of 1, then you know it's going to have a vertex, and the parabola is going to either open up or down based on the sign of the value of a. All right, take a look at question number 2. What is the vertex of the parabola? Well, we learned this last semester. We learned that in vertex form, we know that this is h and this is k. And we knew that when we were finding the vertex, the h variable actually is the opposite of this sign, because vertex form is x minus h. So that means the h value here is just 3. Our k value, we keep the sign. It doesn't change, because vertex form has plus k on the end, so that means our k value includes the sign right here. On the next one, letter B, same thing. This is h and this is k. Because of the way a vertex form quadratic is written, this is actually x minus negative 5. That changes to x plus 5. That's why we flip the sign of h. And then our k value doesn't change because our k value is being added in our vertex form. So there's the vertex of a parabola. Number 3, find the center and radius of the circle. So if you remember this class, let's take a look. In fact, let's look up here real quick. I'm going to write vertex form right here. That is y equals a times x minus h squared plus k. That's why we flip the sign of h and keep the sign of k. Center and radius for standard form. Let's take a look at what standard form looks like. Standard form looks like, I'll try to write it up here real small, x minus h squared plus y minus k squared equals r squared, or radius squared. Now let's look at this. Since we're subtracting h and subtracting k, that means that when we find h and we find k, we have to flip the sign or get the opposite sign than what we see in the equation. So to find the center, that's the easy part. The center, and I'm going to write center here, but from here on in I'm just going to write c. The center here is 7, negative 2. It's actually positive 7 here and negative 2 here. And then the last question is, what's our radius? Well, if you take a look, 64 is equal to r squared. I can write that down right here. R squared is equal to 64 because this number represents r squared. Well, if that's the case, then to get r squared to just change to r, we square root it. So when we square root r squared, we get r. When we square root this side, we can then put that in our calculator and figure it out. So if r squared equals 64, then r is equal to the square root of 64. And in this case, if you put that in your calculator, you will get exactly 8. And we're going to put a unit on the end, or 8 units. There is our radius. So center is 7, -2, and the radius here is 8 units. Let's try the next one. Easy peasy on the h and the k, our center here, and I'm just going to put c for center and r for radius. So the center here is going to be at -12, 6. Let's make sure, if you look at these, make sure they're written in the proper order. Your x variable comes first, your y variable comes second, and then your constant, or your radius, is over on the right side of the equation. So there's our center. And then what's our radius? Well, if you take a look at this one, you see that r squared is equal to 14. If you square root both sides, you get r is equal to the square root of 14. That's your exact radius. But a lot of times on a test, especially if I want you to graph something, you're going to have to change that to a decimal approximation. So let's pull up our calculator and do a square root here. See if I can pull this over. So let's go ahead and put in square root of 14. And that's going to be approximately 3.7. The 4 does not make me round up, so it's 3.7. So approximately 3.7, and I'll just put U for units. All right? Best thing to do right now, class, a lot of these questions on this review sheet have multiple questions under them, so I would pause the video right now and try C and D on your own. Hopefully you've tried those now using the same procedure. We will find the center of this one is at 3, oh, I've got an issue. Before I can find the center and radius, I'm going to have to write this in standard form. That means the y value has to be moved, or the y squared has to be moved to the other side. So our new equation is going to be x minus 3. There's my x terms. They go first. This y squared is going to jump the equal sign. That means it's going to flip the sign, or opposite sign, y squared. And then the radius part, the r squared, that's -49 on the left. We're going to move that over to the right, and that's going to change to the opposite sign, or positive. And now I have enough information to find the center and the radius. First part is the center. My center here is going to be +3, and because our y term doesn't have any number added or subtracted with it inside parentheses, that means I know my movement on my y-axis is going to be 0. And then what is my radius? In this case, my radius is going to be equal to the square root of 49. That's because 49 is equal to r squared. If 49 is equal to r squared, then when I square root both sides, r squared becomes r, and 49 becomes the square root of 49. If I put that in my calculator, I will get exactly 7, so the radius is 7 units. Last ones, take a look. Letter D. Looks like we're in the proper order. Here's my x terms, here's my y terms. My constant is on the right-hand side. Let's go ahead and identify the center. The center is going to be at 0 because our x term does not have anything added or subtracted, so there's no h value. And then my k value is -8. Again, we flip the sign because in the equation for standard form, it's y minus k. And then for our radius, take a look at that. Our radius is going to be equal to the square root of 10. That's because 10 is equal to r squared. So if we square root both sides, r equals the square root of 10. That would be an acceptable answer. That's the exact answer. If you want to get the decimal approximation, you could go ahead and figure out the square root of, whoops, let's clear this. Square root of 10 is approximately 3.16. That means the 6 is going to round the 1 up to 2, so approximately 3.2 units. That covers question number 3.